So this presentation will cover texturing and UV mapping for 3D models and objects. Texture projection is one method that we can use to essentially get a 2D image and a 3D object to be mapped together. And essentially for projection, 3D objects have their 3D coordinate system automatically converted to a 2D coordinate system called U and V. And while this is easy for software to do, there are some downsides. For instance, the software doesn't know your intentions. It doesn't know what the object is supposed to look like. There are typically always some kind of distortion involved, and you're likely to end up seeing seams between certain textures. On the right-hand side, we can see all the various ways, or some of the various ways, that planet Earth has been projected onto a 2D image from a spherical shape. So I mentioned before, UVs are a 2D coordinate system, and this is the way in which we can tightly control how a graphic image can be mapped onto a 3D object. The primary goals of UV mapping are to make sure that our pixel information is in the right spot and to minimize texture distortion as much as possible, and to enable the use of whatever software we might want to use to create those textures in the first place. So we can create a texture in Photoshop, and then we can either create a map in the software, or we can bring the image in and manipulate our map to align with the image. This is an example of what you'll see in pretty much any 3D software package, which is our 0 to 1 UV space. 0 zeros in the origin or the bottom left, and 1 is on the top right. And so all of your UVs will fit in this space. So on the right-hand side, we have a cube in the 3D viewport, and this is the default cube, and it comes with the default UV layout. So on the left-hand side, we have our UV island, which is any UVs that are attached to each other. And the way you can create this, if you don't have a UV map, is you can mark your seams. So essentially where you might think about cutting this object apart with a knife or scissors, and then think about flattening that object out. So you're going to need seams to take a 3D object and have it detach, essentially. Anywhere there isn't a red marked seam in this image would be a continuous area. So here's another example of a more complicated object that is unwrapped. So this is the monkey 3D object in Blender, and you can see on the left bottom that we kind of have a similar looking face to what we have on the right. It's a little bit stretched out when it gets flattened, but you can kind of see where the eyes are, and then where the mouth and nose are on the UVs on the left. And to create that UV layout, I went ahead and marked these seams so that when it automatically unfolded our object, or unwrapped as it's called, it knew how to separate those UVs out. Okay, so to create UV maps, there's a bunch of processes and tools that you can use. Typically, the best results, or the most controlled and precise results, you're going to get by using manual editor tools. So you can add seams and unwrap. There are other tools as well that allow you to scale, rotate, move, attach edges together, edges and UVs together. And then you can also orient your camera and then use the built-in projection mapping methods to almost think of it like taking a photograph of your UVs from various angles and building your UVs that way. So to get to the unwrap tool, you would go up to the UV menu in Blender and then use unwrap. This won't work unless you have marked seams. So if you're trying this and nothing is, or the results you're getting don't look right, that would be why. These are one of the projection tools I mentioned earlier. There's a cylindrical projection method where you can essentially say this object is shaped like a cylinder, and it kind of knows what that shape might look like, and it does its best effort to give you a kind of pre-made UV layout that might give you a good result. As you can see, it's a bit stretched, and we're not getting the top and bottom mapped properly. So to fix that, I would have to maybe look at the cylinder from the top, and then I can select the face of that object, and then I can project from the view and get a perfect circular shape that I can move around in my UV editor. This is an example of UV packing, and UV packing is essentially when you take all of those UV islands and move them as close together as possible. You scale them, rotate them to fit, so there's very little wasted space. And the reason is because anywhere you don't have a UV island, you have that negative space between them. That's essentially unused pixel information. So it's kind of wasted because you're still saving that pixel information to your image, but if you're not making use of it, you're not getting optimal use of your data. And now you can kind of see an example of where I've created a color grid and overlaid that on associated it with our object. And so now we can see where various parts of our color grid are mapping to our object. For instance, D8 on the image on the left isn't going to be represented anywhere on our object on the right because it's not within the bounds of one of those UV islands. So here we are in Blender, and what I'm going to do is quickly show you some of those examples we talked about in the presentation. So if you want to make a color grid, it's easy. We just go to a material that we have applied to our object, image texture. I can create a new one right here from the panel. I'm going to call this color grid. And we can actually select a color grid to be generated for us. And I'm going to make this 2048 by 2048. So it's going to generate an image for us at this size. And everything else is fine. Let's create that image. And we're not seeing anything because we were in solid shade mode. So now we can see this is really nicely mapped out of the box. The reason it's nicely mapped is because if I go to our UV editing tab, you can see the editor on the left has a UV layout already created, and it maps nicely to this grid. Let me go ahead and turn on our preview on the right. So as I move those UVs on the left, you can see how the mapping is changing on the right. I'm going to go ahead and scale. So now our pixels are getting much larger on our object. So be careful if your UVs are small here or your UV islands are very small and take up only a portion of your image. You need a lot of pixel density, otherwise you're going to get blurriness. So just to show you an extreme example, right? So we're just seeing part of this 8 here being represented, and it's very blurry. So we can scale that up so we have more resolution being included on our object. The other thing I can do is I can totally change this layout. Let me find a different object to use. Let's add a cylinder. And let's go ahead and add a material. Let's add that image, that color grid back. And just so you can see the default layout of the cylinder, it's really nice here. We have sort of a perfect unfolded side view, and then we have these circles. I'll show you how to generate these automatically and using our projection methods. So first thing we can do, let's say we don't have our UVs or they're messed up for some reason. Let's say they look, here, let me mess them up. Project from view. So let's say we have UVs that look like this, right? You can kind of see a 3D representation of our object. It doesn't work when we go around here, right? This mapping doesn't really make any sense. We'd have to be looking at it very specifically from one direction. So to fix that, what we could do is try a projection method. So I'm going to select all of them, and let's look at this object directly from the side. Now if I go to UV cylinder projection, we can see it maps this object. It takes up the entire space, the one-to-one space here on the left. But we are getting some stretching. That's because the cylinder wasn't a perfect square shape to begin with. So what I can do is go ahead and scale this down. When I say it's not a perfect square, what I mean is when you unfold it, it's not a perfect square. It's sort of, the circumference becomes flattened out. So then it's really wide like this. So what we're not getting are the top areas. The side areas look pretty good. But if we want those top areas to be correct, what we could do is look straight down, and I will go into face mode. Let me select this face and do UV project from view. And that's because I know my view is going to create this perfect circle. I'm looking perfectly down in my orthogonal top-down view. So now we have that perfect UV representation. Only the UVs you have selected are going to show. So I can move this up here. Let's go ahead and choose the bottom. So if I click on that, I'll get my negative view, and we'll do UV project from view. If I press A and select all of them, now I'll get all of my UVs at once. So now we can see our object is properly mapped on the top and the bottom. We are getting seams, but these are the types of things that you'd want to paint out using a painting tool or Blender's built-in texture painting tools. But that's how you can use a combination of project from view, cylindrical projection mapping to get a UV layout. The other thing I want to show you, if we go to edge mode and I select this edge here and this loop here, we're essentially going to be able to cut the top and the bottom apart. And let me also grab this edge here, and we're going to think about taking in a scissors and cutting that as well. So now this can unfold away from that seam. So I need to go to UV mark seam, and now you can see these red seams. Everything's cut apart, so there shouldn't be much distortion. I'm going to select all and do UV unwrap. And now you can see it's automatically created pretty much the same layout we did manually before with those projection methods, but it was much easier. The nice thing is I can make changes to this object, and I'll always be able to unwrap it fairly consistently with these marked seams. So if something happens to our UV layout, we can quickly get it back. So those are some basics for working with UV tools and the UV editor. So just to recap, UVs help you add image textures to your 3D mesh. There are editor tools that will help you get your mapping fine-tuned and everything in the right spot. If you want to use some of the automatic tools, you have to do some setup work like marking your seams and thinking ahead about how you want that object to unfold. And you can use a combination of projection tools that are built into the software and UV unwrapping and other UV tools to get your UV layouts and your UV maps created. Try to pack your UVs as best you can so you don't waste pixels, and always try to avoid texture distortion whenever possible. Okay, that's going to wrap up our discussion of texturing for this lecture.